Hello dear students, I Ganesh welcome all of you to this session of plus 2 second year mathematics, and today we have to discuss on the topic of binary operation. Already in our previous classes we introduced with the concept of binary operation, and we discussed what is a binary operation, we discussed how many number of binary operations, yes or no, we discussed about all of the properties also. We discuss whether a binary operation is existing or not. When a binary operation is existing, if it is satisfying the closure law, means the elements after the processing, after the result or the final output belongs to the same set. All the things are we discussed in our previous classes. We discussed about the properties of commutative and associative nature of a binary operation. Okay, so binary operation is commutative. If we change their positions, then the result, the output becomes the same. Yes or no? We discussed with examples also. Okay, now today we have to discuss some other properties which are very important in form of binary operation. Okay, that is, today we have to discuss on some of the extra properties of a binary operation. First of all, we will discuss about the existence of identity element. So today we have to discuss on identity element and inverse of a binary operation. Okay, today we have to discuss about the identity. First of all, let us discuss about the identity. Okay, now what we mean by identity? It is very easy, my dear students, so please listen it carefully. Think about a binary operation, that is addition on natural numbers, yes or no, or you can take the addition on integers. So let us take addition, a binary operation which is called as addition. Addition is a binary operation. In our previous class we discussed about it. So let about the addition on what? On Z. Yes or no? Now what a identity means? Now is it a binary operation or not? First of all, let us verify it, which is our we discussed in previous class, but let us discuss today also whether this addition is a binary operation on Z or not. So for it, what we do, we take any two numbers, any two integers from the set of integers. Let one is -3 and another is 10. And now I am putting the addition symbol on them. Okay. Now what the addition symbol do? It converts these two elements to a unique form, to a unique element which is equal to 7. And my dear students, you can see that this addition is a binary operation when the result is belonging to the same set. So you see, the after the processing is over, after the output came out, you see it belongs to the set of integers. Yes or no? As it belongs to the set of integers, so you can say yes, it is a binary operation, as it satisfies the closure law. Closure law means what? The result belong to the same set from where the original elements are taken. You see, the original elements are taken from where? From Z. And the result, the output is also belonging to Z. Yes or no? So you see, this result is belonging to Z. Okay? So as the result is belonging to Z, as 7 is an integer, so it is a binary operation. Okay, my dear students. Now you can verify with some other examples also. Let us take two elements we have to take from Z. Let one is 15 and another is 14. Now if I add them, what I get? I get 29. Yes or no? Is it belonging to Z or not? Obviously it is belonging to Z, set of integers. So we can say it is a binary operation. Okay, this addition is a binary operation. But our point of discussion is on what? Is on identity element. Now, what is an identity element? First of all, let us see with the example, then we go for the definition. Okay, because example, always remember my dear students, example is the better way to understand or to explain some concept. Okay, so let us first go with the example. Now think about the integer. Consider any integer. Okay, suppose I think about 3. Now, is there a element exist which can operate with 3 but it does not alter the value of 3? Now, is there a element is existing which can operate with 3, which can sum up with 3, which can add with 3, but the result does not change? Okay, if such a element is existing, that is called as identity element. That is called as identity element. Okay, and ଆମେ ତାକୁ ଓଡ଼ିଆରେ ଅଭେଦ ବୋଲି କହୁଛେ. Yes or no? Identity element is called as, ଆମ ଓଡ଼ିଆରେ ତାକୁ କ'ଣ ବୋଲି କହନ୍ତି? ଅଭେଦ. Okay, so is there an element is existing which can add with 3 and the result remains same? Okay, yes, it is 0. So you can see that with this binary operation addition, we get a element 0 which can add with 3, which can sum up with 3, but after the process, after the output, 3 remains as it is. So if such a element is existing, that element is called as what? That element is called as binary operation, and that process is called as binary operation, and that element is called as identity element. Say element को कौन बोली कुहाजिबो? Identity element बोली कुहाजिबो. जहाँ सहित binary operation हेला परे मध्य original element, the element does not change the value. Okay, so you can verify also. Now take another element. Suppose we take a element as 7. Now you see with which number 7 can be added. So the value of 7 remains as it is. The value of 7 remains 7. So is there an element? Yes, that is the element 0. So we can see with the process of addition, with the binary operation addition, we get 0 as the what? We get 0 as the identity element. We get 0 as the identity element. Okay. Now we are going to write the definition of identity element. Let us see the definition. In generalizing, I am writing in a general form of the identity element. Okay. Let this star be a, we are ordinarily denoting the binary operation by star. Already we read in our previous class. Let star be a binary operation. Okay. On some set. Okay. On a non-empty set A. Okay, so we are defining the binary operation on the set A. Then an element E belongs to A. So E is an element belongs to A, is called as identity element. Identity element on A if A star E, A operated on E is equal to what? Is equal to A, which can be written as also E operated on A. So what we get is A operated on E. The same result can be operated, we can find it as E operated on A. In both the cases, we can see that it is equal to the original value A. So after the operation with E, the result, the value of the element A does not change. Okay. So if, and what is A? For some element, A belongs to A. So A is belonging to where? A is belonging to set A, and E is also belonging to set A. So if we get that, if we get E for which A star E equal to A, which is equal to E star A, so either A operated on E or E operated on A, in both cases the result is equal to itself, the result is equal to A. So if this is the condition, then that element E is called as identity element. Okay, this is called as identity element, and this is an example of the identity element, existence of identity element. You can see also, again I am repeating, suppose we take a binary process addition on the set what? On the set integer. Now first of all we check it is a binary operation or not. For a binary operation it should satisfy the closure law. So we take any two elements and we can verify the result is belonging to the same set. If the result is belonging to the same set, we can say it is a binary operation. As we take different elements and we operate with them and we see the result is belonging to the same set. Here also we take two different elements, we make the operation with addition and we see the result is belonging to the same set. Yes or no? So it is a binary operation. Now we have to find out whether identity is existing or not, identity element is present or not. If it is present, what is the value of the identity element on that addition, on that process and on that set. Okay. So what we take a element 3, we take a element 7. Now identity means what? Identity means such a element which can operate with 3 but does not change the value of 3. Okay, it remains, the original elements remains as it is. So you can see 0 is here acting as a identity element, because if you operate 0 only with 0 by the in the process of addition, you see 3 remains as 3, 7 remains as 7. We can write also it as 0 plus 3 also. Either 3 operated with 0 or 0 operated with 3. The value of 3 is same. Okay. So it does not change. So which value after the process does not alter is called as identity. So it is 0 plus 7. Okay. So you see 0 is the element which does not alter the value of 7. Okay. So if such an element is there, then that is called as identity element. So here 0 is behaving like the identity element. Later on we will see it with some more examples. Okay. Now what is the observation we made with the concept of identity? You see, one is very clear that whatever, if the identity is existing, then identity element is unique. It is not differing from element to element. Element to element pai se bhinna hebara nahi. Okay, it is unique in nature. It is you can see with 3, 0 is acting as identity element and we get the 3. With 7 also 0 is acting like an identity element. It is operated on with 7 and the value is remaining 7. So you see 0 does not alter. That means in a particular binary operation there is a unique identity element that we can observe. Okay, so I can make it as a note. The note is identity element if it exists is unique in a binary operation. So we can see in a binary operation, identity element, if it exists, that is unique in nature. Okay, so this is the concept of the identity element. Now my dear students, again I am going to tell you what is the meaning of identity. So now we can learn that identity means what? Identity means such an element, to find out the element on a binary process with a given set, that it can operate with every element but does not alter the value of the given element. The value of the given element remains as it is, okay, after the process. So if such element is existing, that is called as what? That is called as identity element. Okay, so this is a concept of identity element. Now we proceed to another concept that is called as invertible element or inverse of a element. Okay, so I am cleaning this board now. Please note down of those things, those are very important. Next we will go to discuss about the about the concept of invertible element or inverse of an element. Okay, first of all, we will see that a invertible element means what, okay, or inverse of an element means what, and later on we check out whether inverse is existing or not. For every element, inverse is existing or not. Okay, that are the thing we have to discuss. Okay, so for it what we do, let us go with the definition and we will show it through an example also. So you see, now I am going to write the concept of invertible element. You see, let star be an binary operation. Let star be an binary operation on a non-empty set A. Okay, consider E belongs to A. So E is ordinarily taken as what? E is taken as the identity element. Consider E belongs to A is the identity element on A, but you know the identity element is defined with respect to a particular binary operation. If the binary operation differs, identity element also differs. So here E belongs to A is called as an identity element on A with respect to the binary operation star. So for the binary operation star, which is denoted as star, for it is behaving like as the what? Identity element. Okay? Is behaving like as the identity element with respect to the binary operation. Okay? Star. Now then we are going to write the definition of the invertible element. Then for an element A belongs to A belongs to A. So if there exists an element A belongs to A, is said to be invertible. So what is the meaning of invertible? Or its inverse exists. So when we can say that element A, some element A which is belonging to that set is said to be invertible if the condition is if there exists B belongs to A. So when A is said to be invertible, if there exists another element B belongs to A such that A star B equal to B star A equal to E. So either A operated on B or B operated on A. In both the cases, the output, the result is equal to its identity. If the result is equal to its identity, then that element B is called as the inverse of A and vice versa. And A is called as inverse of B. Then the element B is called as inverse of A and vice versa. So now let us again try to learn the concept of invertible element. So when the element is said to be invertible, if there is a non-empty set A and a binary operation which is denoted as star is defined on A. Okay? And here E is considered as the identity element with respect to the binary operation star. Now suppose the element is denoted as A, arbitrarily denoted as A, is said to be invertible, or we can say its inverse is existing if A star B equal to B star A equal to E. Okay? So if A star B equal to B star A equal to E, then it is called as, then that element B is called as inverse of A. Okay? Here element B is called as inverse of A. Okay? Now, is inverse is unique? Yes, inverse is unique with respect to a particular element. It is not unique for the total binary operation. It is unique for a particular element. Okay? So I can make it as a note and we will try to learn it through an example. Inverse of an element A if it exists is unique. Okay? So for every element A, if the invertible element is existing, so it is unique for that element only. It is not unique for the total binary operation or for the total set on the given set. Okay? So now we will go for an example to learn the concept of invertible element. Okay, so my dear students, please note down those things. Those are important, the concept of the invertible element. Okay, so please make a note. Okay, now we will go for an example. The example for an invertible element or inverse of an element. Okay, so we will go for an example. Let star be an binary operation on R as A star B equal to AB. As A star B equal to AB. Verify inverse of an element exists or not. Okay, so that we have to verify. So clearly we know as A star B is equal to AB and it is defined on R. So clearly here star is a binary operation. First of all we have to check out it is a binary operation or not. So here we take an example where the star is obviously a binary operation. Okay, so what is given? Given star on R on the set of real numbers as A star B equal to AB. And we have to check out whether it is a binary operation or not first of all. So here we check, here star is a binary operation. Okay, now we have to find out is there existing identity or not, because for inverse first of all we have to check that there is existing an identity. Okay, if identity is existing then clearly we can say that inverse can exist. Okay, and inverse of a particular element can exist. Okay, so you see first of all we check out inverse is existing or not. Consider E belongs to R. Now A star, how to find out or how to check out inverse exists or not? First of all we go for the identity. So now E belongs to R, some element E is belonging to R, and if we claim E as the identity element, A star is how much? It is equal to AE as per the definition. So but we know A is equal to what? A is equal to A if A is called as the identity. That implies you can see if A equal to A, then what is the value of E? E is obviously equal to 1. Okay, so is the identity. Is the identity. Okay, so E equal to 1 is the identity at here. Now, so we obtain the identity. Now we go for the inverse. Now we check out whether inverse is existing or not. For existence of inverse we are now consider for A belongs to R, there exists B belongs to R such that A star B equal to E. Now E is equal to 1. Okay. So here B is called as inverse. Now we are going to check out whether inverse is existing or not. So we know what is the value of A star B. A star B equal to AB. It is defined. And AB should be equal to identity. But here identity is equal to how much? 1. So you see, what is the value of B? So B is equal to 1 on A. So what is the value of what is the value of B? B is equal to 1 on A. So you see, for every A belongs to R, therefore for all A belongs to R, there exists B equal to 1 by A, which is also belonging to R. So we can say that this set, in this particular binary operation, we will able to get invertible elements, or we can find the inverse of the elements. Okay, therefore we can say inverse is 1 by E is equal to 1 by A. Okay, for every A, its inverse is 1 by A. Okay, yes or no? So this is the concept of the what? This is the concept of the invertible element. Okay, my dear students, look carefully the concept of invertible element. Okay, and my dear students, please make a note of those things and try to learn. Okay, next we will go for another example for your clarification about the invertible element. So I am cleaning this one. Please make a note of those things. Okay, again I am repeating. So you see, we go for another example of existence of inverse to check out inverse is existing or not. For it, what we took another example. Consider the binary operation star on Z, A star B equal to A plus B. As consider star on Z as A star B equal to A plus B. Verify star is a binary operation or not. Then next, find identity element if it exists, because to get the inverse we should find out the identity. Next, find inverse of A belongs to Z if it exists. So you see, here I am writing a example where we have to check out a binary operation is a process is given. So first of all we have to check out it is a binary operation or not. Next we have to check out the identity is existing or not. Next we have to check out the inverse is existing or not. Okay, so this is an example. Okay, so let us go for it. I am writing the solution. So given star on Z as A star B equal to A plus B. So this is the definition given. This is the binary process is defined. Okay. Now you see it is a binary operation or not. Okay. Yes. What you think, my dear students? It is a binary operation or not? Yes, it is a binary operation. Why? Because you can see that here the binary operation is in this format a plus b, and a plus b means the addition is there. So you know addition is satisfying the closure law on set z. Okay, the result is belonging to, if we take integers, the result is also an integer. So it satisfies the closure law, hence it is a binary operation. A star satisfies the, so I am writing the first one. A star satisfies the closure law. Therefore, star is a what? Binary operation. So next we will go for one by one. Okay. Next we will go for identity is existing or not. Now, what is the concept of identity? Yes, identity means what? Identity means such a unique element which is existing in a binary operation, and it is that element which operate with each and every element but does not alter their process. Means what? Means after the result, after the final output, the values remain as it is. Okay. So if I say consider E is the identity element. If E is the identity element, then A star E equal to A plus B, and we know that this result is equal to itself the value of A. That is the nature of identity. Okay. So from there, what we get, E is equal to 0. So in this binary process, our identity element is equal to 0. It is belonging to Z. Okay. So we obtained the identity element. Now if identity is obtained, now we go for the inverse of an element which is belonging to Z exist or not. Okay. That we have to check out. How to check out? Consider A belongs to Z. A is belonging to Z. If A is belonging to Z, therefore consider B is its inverse. B is its inverse. So generalized way we are telling that B is its inverse. If B is its inverse, therefore A star B, which is equal to A plus B as the binary process is defined, it is equal to 0. Because the result, if it is the inverse, the result is belonging to the, what is equal to the identity. So B is equal, A plus B equal to 0. So from there, what we get the value of B? We get the value of B as minus A. Okay. So we can see that our inverse element is equal to minus of A. So if there is an element A in this process, its inverse can be written as minus A. So if somebody asks you that what is the inverse of 3 belonging to Z in this process? Okay, so the inverse of 3 in this process is equal to minus 3. Yes or no? So in this way, we are able to define the inverse, or we are able to find the inverse of an element by such type of process. Okay, so this is an example to find the element invertible or not, and to find the inverse of a particular element. Okay. So this is one of the example. You see it? Okay. Next, we will proceed to discuss a thing which is called as composition table. Okay. And composition table means what? It is a diagram to show all the binary operations. Okay, a binary operation is given on a set, and remember this diagram, this composition table, or you can say the operation table, can be drawn if the set is a very minimum number of elements are there. If the set is larger, this composition table is not helpful. Okay, but if it contains some few elements, then we are able to show a binary operation through composition table. Okay, so next we will going to discuss about the composition table, or which is called as operation table. So next our concept is on the composition table. So I am cleaning the board now. So we are writing, I am writing the topic of discussion, that is composition table, or it is also called as operation table. Okay, composition table or operation table. So what is a composition table and a operation table? Let us begin this discussion. Okay, so for it, this is a table, or this is a representation to find out all possible operations of a particular set with a particular operation mentioned, and it is helpful if the set is containing small number of elements, a few number of elements. Okay, so I am writing it. Let, and later we will go for an example. Let A be a non-empty set, and that set should be contain a few number of elements. Okay, then only it is possible. And let star be an binary operation on A, then be a binary operation n on A, then we can draw. So if there is a set A with a binary operation star, then we are able to draw the composition table. Okay, then we are able to draw the composition table. And the composition table, what it do? The composition table describe the operation with the help of the elements. Okay, so then we can draw the composition table with the help of elements and with the given binary process to describe all the properties as follows. So you see what we have to do. I am writing it, then again I will describe you. Suppose set A, suppose A has the elements A1, A2 and up to AN. Okay, now how it is describing, how the composition table is drawn. So it is the binary operation star is there. So it is your A1, A2, A3 and so on, it is up to AN. Okay, and now it is your A1, A2, A3, and so on, it is your An. In this way, we have to represent the elements. And how to fill this value? After the operation, S star is defined as that, we have to fill up these as A1 star A1. The result is written at here. And again it is written as A1 star A2. Again that is written as A1 star A3. And so on, it is written as A1 star An. Then how this one is filled as A2 star A1. This is A2 star A2. Okay. Then next one is A2 star A3. Okay. And so on, it is A2 star An. Similarly, this one is A3 star A1, A3 star A2, A3 star A3, and so on, it is A3 star An. Next, similarly, the last one is An star A1, An star A2, and so on, it is An star An. Okay. So this is the way to define the composition table. Okay. You see it, and we will discuss about the properties. And all the properties, as I told you, the composition table describe all the properties. So we will go for one by one property. Okay. So now we describe about the properties of the composition. What we observe? You see, after drawing the composition table, you can check out it is a binary operation or not. It is a binary operation or not. So when it is a binary operation, if all the elements, all the entries, what we calculated here belong to set A, means these results belongs to set A, then it is called as a binary operation. So we can check out after drawing the composition table, we can check out it is a binary operation or not. Okay. So what are the observations? The following observations I am writing one by one. Okay. So let this table is at here. I am writing it here. Okay. I am clearing this one. So what are the observations we find? So first of all, the first operation is the observations from composition table is between. If all entries belongs to A, then star is the binary operation. Okay, so we can verify that this binary process is a binary operation or not from here. If all results belongs to what? Belongs to set A. After the calculation, all the results belongs to set A, then we can say it is a binary operation. Okay. Next, what we can observe from the composition table, that star is commutative. We can verify the commutative property also. Star is commutative. Okay, in the composition table, from the composition table. Okay, in the composition table. So when we can verify it is commutative or not? Okay, if it is symmetrical, if it is symmetrical from top of left corner to bottom of right corner diagonally. Okay. So from there we can observe that it is commutative or not, or simply if we check out that A1 star A2 equal to A2 star A1, if the results are same, then we can see which is written that it is symmetric. Okay, this one is equal to this one. So if it is symmetric, then from left corner to bottom of top of left corner to bottom of right corner diagonally, then we can say it is commutative in nature. Okay, yes or no? Next we will go for the identity. You see, so now we have to clean the board, or I am cleaning these two. Okay, for your information, let the composition table is it's at here, and I am going to clean the board. So next, what are the properties there? The properties are the existence of identity is existing or not. So bit 3, it is the set A. Is the identity element found from composition table. So when we find that E is the identity element in the composition table, okay, if so we have to find out that E is the identity element in the composition table if the result A star E equal to A. If the result A star E equal to A with the help of this binary process, So if we find that after the operation a particular element is existing, okay, which can operate with the every element, but the result is equal to itself, then E is called as the identity element. Okay, next we will go for the inverse and check out the inverse is existing or not. For it I am cleaning the board now. It is the last one, the next property. So all the things can be verified from the composition table. Okay. Now from composition table, inverse of an element A, belonging to what? Belonging to set A can be found if A star B equal to E. If A star B equal to E, here B is called as inverse of A. Here B is called as inverse of A. So from composition table we are able to get that a process is binary or not, it is commutative or not, it is identity existing or not, inverse of every element is existing or not. If the inverse is existing, what is its value, and the result is belonging to the same set or not. Okay, so all the properties can be verified from the composition table. Okay, but we can learn it better. Now go for an example to clarify all the things. Okay, so now I am going to tell you an example to clarify about the composition table with an example. So I am writing an example. The example is about the composition table. Okay, let's start. Define on A, and what is A? A is containing the elements. A is containing the elements 0, 1, 2, 3, 4, 5. Okay, so set A is the element. Set A is the set containing the elements 0, 1, 2, 3, 4, 5, H. And how the operation is defined? As A star B equal to A. So what it means? It means A plus B modulo 6. So the remainder obtained when it is the sum is divided by 6. Okay, so that it means. Okay, so now what we have to, the question is given, is star is a binary operation, as we are telling that all the things can be observed. So this is one question, is star is a binary operation. The next one is star is commutative. Is star is commutative. Then next one is identity is existing. Is identity is okay existing. Next one is star has inverse element or not. Okay, so that is we have to find out at here. So now we will proceed. You see, so I am writing the solution. Given A equal to 0, 1, 2, 3, 4, 5. Okay, and what is A operation B? Also A operation B equal to, it is A plus B modulo 6. That is written. Okay, this is equals to, this symbol is equal to A plus B modulo 6. So the composition, now we have to draw the composition table to verify all the things. Therefore the composition table is as follows. So how the composition table is drawn? It is 0, 1, 2, 3, 4, 5. Okay, again it is 0, 1, 2, 3, 4, and it is our 5. Yes or no? So in this way we can define the composition table. Now we have to fill these things. Now 0 is operated with 0. If 0 is operated with 0, 0 operation 0 is what? 0 plus 0 modulo 6. And what we obtain? We obtain the remainder as 0. Next, 0 plus 1, it is equal to 1. 1 modulo 6, when 1 is divided with 6, the remainder is equal to 1. Similarly, 0 operation 2, we can obtain 2. And similarly, 0 plus 3, 3. 0 plus 4, 4. 0 operation 5, it is 5. And 1 operation 0, it is 1. 1 operation 1, it is 2. And because it is the remainder obtained. And similarly, we can fill all the things. Okay. It is our 3, it is 4, it is 5. And here we are obtaining it as 0. Because 1 star 5 means it is 1 plus 5, 6. 6 is divided by 6 and it is the remainder is equal to 0. 2 operation 0, it is 2. 2 operation 1, it is 3. 2 operation 2, it is 4. The remainder is 4. 2 operation 3, it is 5. Remainder is 5. 2 operation 4, it is remainder is 0. 2 operation 5, it is 7. 7 with divided with 6, the remainder is 1. 3 operation 0, 3. 3 operation 1, it is 4. It is 5. It is our 6 and the remainder is 0. So it is again 1. 3 plus 4 is 7. So 7 modulo 6 is 1. So 3 plus 3 operation 5 is 8. So it is 3 plus 5, 8. When 8 is divided with 6, the remainder is 2. Okay. And 4 operation 0, it is 4. Again 4 operation 1, it is 5. It is 6 and the remainder is 0. Again I am filling all the things. 5 operation 0, it is 5. Next it is our 0. Again it is 1. It is 2. It is 3. It is 4. Okay. Now we have to check all the things, as we are suggesting that binary operation is helpful to check out all the things, a operation is binary or not. You see, after the processing, all the elements are belonging to the same set, same A. Yes or no? So it is the binary operation. So the conclusions, therefore, bit 1. Therefore, as all entries belongs to A, therefore star is the binary operation. Yes or no? And we can say now it is commutative or not. You can see 1 star 0. 1 star 0 is 1. And we will to see 0 star 1. It is also 1. As it is symmetric. Okay. So here star is also commutative. It can be verified. Okay. Is identity is existing or not? That is very important. Is identity is existing or not? You see, identity means what? It is the element which operate with every element but the value remains same. Okay, the original elements remain same. You can see that 0 is behaving like the identity because 0 is operated with every element with itself and value remains 0. It is operated with 1 operated 0 is 1. 2 operation 0 is 2. 3 operation 0 is 3. 4 operation 0 is 4. 5 operation 0 is 5. So from here the next conclusion is, what is the identity element? Here you can say 0 is the identity element. Here 0 is the identity element. Next, we have to find the inverse. Inverse of, as we know, inverse of every element can found or not, that we have to check out. You see, inverse means what? We have to verify it. Again I am showing it at here. You see, Here I am writing so up to bit 3 now we are clear. Now we are moving to bit 4. As you can see that inverse means what? Inverse means after the process the result is equal to the identity, then the elements are inverse of each other. That is the meaning of inverse. Yes or no? So you see here 0 is the identity. So 0 operated with which element it is equal to identity. So you can see, we can observe 0 operated with 0 equal to 0. Yes or no? We can observe now for 1, what is the identity? You see 1 operated with 5 which is equal to 0. So again we can write similarly 1 operated with 5 it is equal to 0. And 0 is the identity at here which is equal to also 5 operated with 1. Yes or no? And we can write 2 operated with what? 4 and it is equal to 0 and it is equal to 4 star 2. And 3 operated with which element? 3 operated with itself equal to 0. So we are getting the identity elements when 0 is operated with 0. Therefore, inverse of 0 is 0. Inverse of 1 is 5. Inverse of 2 is 4. Inverse of 3 is 3. Inverse of 4 is 2. Inverse of 5 is 1. Okay. So we are able to get the inverse elements. Okay. And you can observe that inverse of each element is unique and differs to other elements. Yes or no? So this composition table, after the computation is over, it helps us to check out all the properties of a binary operation. But my dear students, you can draw this composition table if the given set is smaller, means containing few elements. Otherwise, how you can draw a larger? It is very hard in your part. Okay. So draw the composition table when it is the set is containing few number of elements. So my dear students, today we discuss about the concepts of identity element, about the concept of inverse of element and the composition table, and we discuss the properties of identity and the properties of inverse with the help of how to verify it with the help of composition table. Okay. So with this, our binary operation is now covered. Okay, my dear students. So we rested here and we meet in our next class with some new topic. Till then, thank you and thank you to all. Goodbye.